Okay, welcome back to Data Science at Home. In this episode, I would like to answer some of the, in my opinion, one of the most interesting, some of the most interesting questions that I've been asked via comments on Discord, via email, and so I selected some of them to make an episode about it. It's going to be mainly about AI tips and tricks, as I call this episode. In particular, it will be about RAGs and information that is retrieved by somewhere. Typically for institutions or these relatively critical environments for which using a frontier AI model is not an option. Okay. And of course, before we start, I would like to thank all the followers on YouTube. The channel is growing. Keep subscribing. That's, as I said, my currency. I'm very glad that you like the show, and the number of subscribers is increasing kind of unexpectedly, which is always a good thing. All right, so let me start straight to the point. The very first question is, what is RAG and why does it matter for institutional knowledge? So when I mention institutional knowledge, I typically refer to these organizations for which hitting an OpenAI API or an Anthropic API is not an option, right? So this means that these organizations typically have a quite strict requirement, which is my data cannot go outside of the company, right? So it's called data residency. And in all these cases, considering a frontier AI model is not an option, at least not for everything that the users are asking, or the employees of the company if it's a company. So the very first thing I want to mention is what is a RAG? Well, a RAG is essentially a system, it's a pattern, in fact, that allows you to maintain a local knowledge, so local documents that are typically embedded. So this means that the way you search for these documents is via vector. Vectors. It's called vector search for a reason. So the document per se is indeed converted into an embedding vector of several hundred dimensions. I don't want to get into the details because different embedding models use different dimensions, but the idea is that you convert that text document, but can also be an image or any other media, into a numeric vector that you can search, or against which you can calculate some kind of distance or similarity, typically cosine similarity or other metrics. Now, there is a... why does it matter? Well, it matters because the documentation, the knowledge, let's say, that you have in the institution doesn't necessarily need to go out. And also, it's you can maintain that in on-premise or in our virtual private cloud, first of all. But also, this information will be, first of all, fetched. We'll see how later. But also used and injected into the prompts so that a large language model would be generating a response based on this, let's say, private information that the company has. And so that's a very powerful tool because as we have realized many, many times when we build these things, is that a good RAG system with a much smaller model in terms of numbers of parameters, a large language model, can be a lot more performant, if not as performant as a frontier AI model of several billion parameters. Plus, it would allow you to maintain what I call data residency, which is the fact that your data doesn't necessarily need to be outside of your organization, which is also can be a strict requirement for many organizations out there. So when you speak about RAG, you speak about a system, not just a single tool. And the system allows you to do several tasks, several steps, let's say, or phases. The first is the ingestion, ingestion and structuring, where data quality wins in a way. So here you have, for example, parsers that allow you to handle PDFs, emails, embedded tables, images, if you do images, etc. Then you have some form of chunking. We'll cover the chunking step later in this episode. And then we have metadata enrichment. We have you can use graph augmented approaches. There is much more there, but ingestion is essentially taking the document and transforming into a vector. The second step or the second phase is the retrieval phase. So here you can use dense retrieval or sparse retrieval, depending on which type of search you're doing. Sparse retrieval, for the record, typically is using BM25, which is a way to do lexical matches. So you search documents by keywords, tags, the traditional way of searching stuff. And the second type of retrieval is the dense retrieval, which means you are using the vectors, and so you are vectorizing the queries in order to look into your RAG system and see and fetch the documents that are similar to the query. How you do that? With vector databases, typically with vector search. And finally, you have the generation, typically with guardrails. So, for example, if you use an open source model or a smaller model in general, like Llama, Mistral, GLM, whatever, so you control, in fact, the inference and data residency. And then what you do, you typically create, you have a prompt template in which you inject the fetched documents, the retrieved documents. So the retrieved documents, which can be chunks, sentences, phrases, entire paragraphs, or entire documents, you inject them and you make them part of the prompt, so that when you pass the prompt to a large language model, now the large language model has pretty much all the information or most of the information required to generating a response. While in a frontier AI model, this doesn't happen, because you typically rely on this big model that you assume will have all the information that you need. The model per se will have a RAG system eventually. So at OpenAI, they're definitely using some kind of RAG. You just don't have access to that. You don't have visibility to that. And also because they are building models that are kind of good for everyone. So they are building these frontier AI models that are perform pretty much on every sector, while yours can be very specific, can be very narrow. So the second question is, how do you handle hallucination in RAG systems? And that's a terrific question, because hallucinations can still happen. And we know that large language models will always be affected by hallucinations by definition, by the way the models are designed. It's a feature, not a bug. We said that a number of times in different episodes. So how do you handle hallucinations in RAG systems? Well, hallucination can happen in different ways, and in fact at different stages of the entire response generation. At retrieval time, so you are essentially retrieving the wrong stuff, right? At generation time, so your prompt is probably not adequate to that particular RAG system, which means that maybe you are fetching the right things, you are just not using these retrieved documents the proper way. So probably you want to do some prompt engineering there. So how would you fix this? Well, you need evaluations. So you typically do these weekly audits, especially when you're dealing with organizations for which quality is important, or the domain is critical, for which a wrong response might affect the rest of the company in many possible ways, not just money, but also commercial processes. Well, in that case, you do weekly audits. That's what we typically do at my company, Amethyx. We sample a certain number of responses, and then we do fact-checking against source docs, right? Another way to do evaluation is a user feedback loop. So you flag responses marked as incorrect, and then you retrain the retrieval. And for critical domains, think about legal, compliance, all that stuff. You definitely want to implement some kind of human-in-the-loop validation. So again, RAG systems are definitely there to mitigate the problem of hallucination, though they do not remove the problem of hallucination entirely, because still the large language model is still generating a response. Now, if the prompt is good, the prompt template is very well designed, is very well engineered, these mitigations might not occur, but it's not excluded that they will. This is an interesting question, is what is semantic chunking and how does it differ from fixed size chunking? So here is like the biggest misconception, in fact, when people use RAG systems, is that it is in the chunking strategy. So when you chunk a document, let's assume you have a relatively large PDF. In that PDF, you convert that PDF into text, you parse the PDF, and now you have your text. Now, what happens is that in that text there are many concepts. Okay, and so what you want to do, you want to create these concepts. We want to create the RAG document. The RAG document is not the real document. It's not the original document. One real document, like one PDF, is usually converted into many RAG documents, which are these chunks that you extract from the document and then you vectorize and you keep in your RAG system. And then what you usually do is that you connect this concept to the same document. So if you have some kind of attribution feature, the retrieved documents can be redirected to the one original document from which they come from. But that's not the point. The point is, how do you actually chunk an original document like the PDF? Well, there are many strategies. In fact, there are only two strategies. The first is the traditional one. You have a list of separators, like a period, a dot, or commas, new lines, etc. And you start chunking. You start separating. Generating sentences, and putting them into the RAG system. There is a problem with that. Humans tend to separate things, especially if you're not a writer, you don't follow the writing rules. You might be using dots and new lines kind of, not in an adequate way. And what happens is that you might be generating documents, RAG documents that are pretty similar. But they would still be considered different because they're separated by a separator. Well, in that case, you are polluting the RAG system with similar concepts for which typically the embedding vector would be more or less the same. And you would start, retrieving things that, should not be retrieved multiple times. That could be, in turn, a confounding factor for the large language model, which will have, a certain, number of retrieved documents that look exactly the same, that will monopolize, let's say, the semantic of the conversation towards that, high presence of similar documents. So you probably want to avoid that. So another strategy that you typically apply for chunking is called semantic chunking. So semantic chunking is a very smart way because it uses an embedding model to, you first separate as you did before, but then you tend to merge sentences or pieces that are semantically very similar. So this means that you start merging these things, and now you have, instead of having like 5 sentences, which would be 5 RAG documents in your RAG system, now you would have one chunk made of 5 sentences, and you vectorize that entire chunk instead. So now in your RAG system, you would have one document instead of 5 very similar ones. So in this way, you kind of have some kind of deduplication already at the source. And also this improves typically the quality of the retrieval. So semantic chunking versus traditional chunking, they are very different. And of course, there are many other technical aspects that I'm ignoring now. For example, what would be the minimal threshold to consider two things different, semantically different, and so on and so forth. But semantic chunking typically, generally speaking, performs better than fixed size chunking or separator-based chunking. Explain dense retrieval embeddings. What are the trade-offs? Well, dense retrieval is essentially what RAG systems have been designed for. So you have documents that are vectorized, and so you use vector search, typically, the embedding, to search for this, to retrieve these documents. So what happens typically is that if you have a query, you need to embed that query using the same embedding model. And then using that vector, you use that vector to fetch similar documents to the query so that you can retrieve stuff that are semantically related to the query that you're asking. And if these two things are using the same embedding model, it's typically that, okay? So that if you type a query, you typically get, unless the query is quite exotic, you typically get documents that are indeed pertinent to that query from a vector point of view. Now the trade-offs, of course, this is, this works at a semantic level, so can be more accurate than, traditional searching. The trade-off, of course, is that you need to embed things, you need to apply cosine similarity. If you change embedding model, you need to re-embed everything. Probably there is a question about that. So, there are some complications there. Plus, the embedding model can be, embedding stuff can take some time. And then there is the chunking problem. No chunk is a bulletproof to everything. So the chunking strategy actually plays a role there. When would you use hybrid search instead of pure dense or sparse? Well, it depends. I would essentially consider still traditional search or sparse search for scenarios in which there are, for example, a lot of acronyms. And typically, organizations that operate in very narrow domains, they use a lot of jargon and a lot of acronyms that are specific to that particular sector, sometimes even specific to that particular company. So there are this way that people call things that are very specific. OT can mean off topic, out of time, or Old Testament, depending to who you're talking to. If I know that OT in my particular domain, or in my particular institution means off topic, let's say, well, I would like to match that exactly. So in that case, I would like to use a hybrid search instead, because first I want to capture the, let's say, the acronym with the lexical parsing, with lexical searching or matching. And then I also want to embed that thing to off-topic, so to a vector that determines the meaning of off-topic with in semantical meaning of topic, and not Old Testament, which is valid again only for my particular domain or my particular company. So in that case, I would definitely use some kind of hybrid strategy because a frontier AI model would definitely be confused. How would you fine-tune embeddings for your domain? That's a tough one. I've seen that people have the tendency not to fine-tune stuff anymore. That was some kind of academic exercise when models came out. I highly recommend when things are very narrow domain. Of course, there is a big, a big if, is that if you're using models that you control. So if you're using open source models, local models typically, that you also control the embedding layer, then you can do these things. Otherwise, you typically cannot. But there is a nice decoupling between the two, because you might be embedding stuff for a RAG system with a specific embedding model, and then you might be using even a closed source LLM. You can perfectly do that. Now, my embedding system is local. I fine-tune my embedding model for these documents, for my particular documents, and I use that embedding model just to retrieve the documents and then pass them to the closed source, let's say, frontier AI model or another local model. So the two things are very disconnected and very decoupled in a way. You need to have a control, of course, of the embedding model. Now, how do you fine-tune an embedding model? Well, if the model is local, what we typically do is making sure that you have at least 500 to 1,000. That's kind of the sweet spot. 500 to 1,000 documents that are specific to the business, specific to that particular domain, and you use them to retrain or to fine-tune, in fact, the embedding. Fine-tuning means not retraining everything. It means typically changing, with the low-rank adaptation kind of, training the last layers of the model. Same thing goes for fine-tuning a large language model. Again, when you have full control of it, you typically use a low-rank adaptation to, let's say, retrain only the last layers. in fact, you don't actually retrain the last layer. You retrain a matrix at the end of the model, and then you use that. So all the layers of the model stay pretty much intact. So yeah, that's what I would do, making sure that first you have this type of data availability. If you have less than that, it's not going to work. You better go with a hybrid search that allows you to do lexical match plus whatever the embedding is finding. At that point, you can weight the two types of search strategies and tune the weights according to your system and live with that. Do you need to re-embed all documents when you fine-tune? Short answer, yes. Long answer, yes, of course. Obviously, you need to retrain. Every time you re-embed all every time you fine-tune, you need to re-embed everything. Even when you use a tiny amount of documents to fine-tune your embedding model, you still need to re-embed everything because weights are dense, so they might have changed even on documents that you never saw during the fine-tuning. And so things can be actually very, very different. So don't assume that when you fine-tune on a particular type of document, only the embedding of that type of document will change. No. It's a dense vector, so it will change. It might change even in the documents that were not part of the training set. And that's why you need to fine-tune, to re-embed everything again. Now, of course, you can have a pipeline that does that overnight. But yeah, that's the complication that you need to take into account when you fine-tune. That's probably one of the reasons for which people have the tendency to patch things rather than fine-tune, because fine-tuning requires to re-embed everything. And also for scenarios in which there is business continuity to maintain, re-embedding all documents might be difficult, if not prohibitive. Think about, you have a million documents in the company, and you need to maintain the system running. You cannot decide to fine-tune things, because then you have to re-embed all the million documents overnight, and overnight is not even sufficient. So there are these type of complications that is more engineering problems rather than AI problems. Why would you choose open source embeddings over OpenAI? Well, simply because I can control my model, first of all. As I said, if you need to get a vector from a document that you cannot send outside of your organization to OpenAI or whoever is the frontier AI model you are renting, well, that's a no deal, right? So there's no other way to extract an embedding if that document cannot move. So in that case, yes. Another reason is that I might want to fine-tune, so I need to have access to the embedding model. It has to be a local thing, and definitely open source, because I need to know the topology of that model. I need to have access to the weights, and then there are many Python scripts that it's now template code. I consider it boilerplate code now, because there are so many strategies in PyTorch, for example, to fine-tune an embedding model that you control, of course. OpenSearch versus Quadrant, which would you choose and why? So I don't know OpenSearch very well. I know they're both vector databases to start with. I worked a lot with Quadrant, which is written in Rust, phenomenal piece of software, and very fast. The biggest difference is that OpenSearch is also a very interesting project, definitely used in the enterprise as a vector database. OpenSearch has lexical match using BM25 and other metrics that Quadrant doesn't. So Quadrant only does vector search. That's kind of the limitation of Quadrant. But I personally have seen Quadrant performing a lot better than OpenSearch on a relatively large number of documents. It's a very nice piece of software. It can run as a standalone, a bit like SQLite, but it can also run as a service, a bit like Postgres. The API subsystem is absolutely great. It's very well written. It's written in Rust, and you probably know by now how much I like Rust. So yeah, it's my choice would be there. How would you design a vector database infrastructure for 100,000 documents? Well, that's a big story. Let's see. There should be a pipeline to start with. The first is the fetching part, so all the connectors, right? So, first of all, designing a vector database infrastructure is something that you need to think of starting from the type of documents that you want to ingest, right? So they can be simple documents, text documents, but they can also be database tables or documents living in external databases. You might have to ingest emails or other forms of documents coming from archives and so on and so forth. Now, the pipeline architecture that I would design would consist of different stages or different steps. The first is the fetching part. So each data type would be fetched different way. So the so-called connectors, essentially. RAG documents would be behind the typical vector search, but emails would come from a particular IMAP API. File system documents would be would be coming from a file system, and so on and so forth. So depending on where the document is sitting, you would use different connectors. So that's the fetching aspect. The second step is definitely about normalization. So what is normalization is transforming heterogeneous data, diverse data, into something that is homogeneous for the system. So think about, you have a PDF, you have a Word document, you have images. Now you want to normalize these things, which means that you want to transform the PDF into text. So you want to extract text from a PDF using, I don't know, PyPDF, PDF Plumber. There are many software and scripts there. Same for Word documents, so like Python docx and several others. Images, you want to use some kind of OCR to extract text from images. Tesseract vision models, etc. So once you have that, now you have a normalized documents, right? They all look like text now. The third step would definitely be about deduplication, which is a way to, I would do that very early in this, very early stage, deduplicating stuff. You definitely want to avoid duplicates on your RAG system or a vector database in general, because if they get fetched multiple times, they get retrieved multiple times, they might be polluting the prompt later. And a polluted prompt later means that a particular concept might be over present, and that would definitely unbalance the prompt entirely. Would give a lot more emphasis to a concept just because it's duplicated, and that will in turn impact the response for the large language model. And it's going to be quite hard to track this. So try to deduplicate as early as possible. The other thing I would do is versioning. These are the steps that I'm mentioning now that we constantly do at Amethyx for commercial projects pretty much all the time. Then, of course, as I mentioned, the chunking strategy. So that's part of the design. Chunking strategy is a fundamental concept that people typically overlook. And so that's something I would definitely make part of the designed architecture. And finally, quality checks. This goes without saying. Empty documents, duplicate paragraphs, very very old content that it's no longer valid. For example, you want to maintain this, and you want to check the quality of the retrieval. Probably there is a question later, because again, garbage in, garbage out, also in large language models. So as it was in machine learning, right? If you remember that. If you pollute the prompt with something with retrieved documents that should not be there for whatever reason, you are definitely exposed to a very bad response or an inappropriate response. And the 100,000 documents, well, that depends, that gives me more idea of the scalability. I would definitely tend to separate these things more in enterprise fashion. So having the vector database, all the APIs and the connectors are separate things so that you can, for example, increase the number of connectors without affecting the actual vector database. You can have the quality checks and the quality check strategy separated from the rest. So you can, these are all modules that you can replace anytime or improve separately from the entire system. That will allow you to identify typically the bottlenecks of the system and then replace things as they need. For example, if you realize that your normalization strategy, your normalization phase is not efficient and is not accurate, you can just replace that part. So if you have a modular system, you can maintain the entire pipeline intact and just replace the normalization phase of the entire pipeline. And now instead of using, PyPDF, you want to use your own custom PDF text extractor, that's fine. As long as you maintain the compatibility of the APIs, that block, that module can be replaced anytime without affecting anything. And once you identify the bottleneck of the system, of course, replacing that bottleneck will improve the entire system overall. When would you use a large API model, a large API-based model versus a smaller open source model? Well, maybe I'm gonna repeat myself here, but there are some reasons, commercially viable reasons, for which you definitely want to, you prefer a smaller open source model. So I typically have this. It's not a formula, of course. Nothing is valid everywhere for everyone. But I typically choose API models like GPT-4, 5, or Claude, etc. When you need very complex reasoning. So think about legal interpretation or multi-step logic. For this type of tasks, you need a big fat model. Ignore the fact that you can run. You might have a very nice GPU at home, but it's not gonna be sufficient. These are systems that require several 100 billion parameter models, so you cannot run that. So if strictly necessary, just use them because there's no other way, unfortunately. Not yet, would say, but okay. You choose open source for regulated environments typically, so data residency. That for me is a no-brainer. As soon as a client tells me we need to maintain data, like data cannot get out, that's already, that made the decision to me. Another reason can be economics, like high volume, so the cost per query matters. SMEs typically have this problem. I've heard of SMEs who were almost bankrupt because they, quote unquote, forgot the API was running, and more and more employees were using things, and at the end of the month they got a nice bill from OpenAI. The first bill got paid, of course, the second one was not, and the third one, the system was shut down because that would have crashed the company. That can happen. So if you have a high volume number of queries, you might be considering of making that investment, because high volume queries might definitely bankrupt you if you use a frontier AI model, while in a local model, of course, you have an initial investment on the infrastructure. You have maintenance investment, maintenance costs as well, system administrators, developers, etc., engineers who have to, put the stuff up and running. So if you make the math, if you do the math, sometimes it's much more convenient when you have a certain, a minimal volume of queries from your internal users. If the domain is narrow, in my opinion, that's another very good sign not to use frontier AI models, because if the domain is narrow, it means that likely a good RAG system and a small local model can perform, typically as good as a frontier AI model. Of course, you need to maintain your RAG. You need to build your RAG system and maintain it, semantically correct way and consistent. But that's a task I would do regardless, because strong local knowledge plus small models are typically better than big fat models with bad local knowledge. Don't know if I get the point. Listen to that again, and you probably know what I mean. So then there are, hybrid situations in which you can start with an open source for institutional knowledge. Think about a Llama 70 billion parameter model, which is a very good model, by the way, or a Mistral mixture of expert 8 by 7 billion, also a very good model. And then you can say, for example, 80% of the stuff Q&A, you use smaller models plus my good RAG, which works equally well. And then I can have a fallback to GPT-5 or Claude for complex queries. If you do that, you are hitting the frontier AI model maybe 30-40% of the time rather than 100%. And that would cut the costs by a nice amount. Your bill at the end of the month will be a lot lighter. We did that for a client some time ago. The numbers were approximately 100,000 daily queries, internal queries. They were using agents. Of course, it was not many users, human users, but there were a lot of automatic agents. So the number of queries was approximately 100,000 per day. A Llama 73 billion parameter model, I'm giving numbers a bit by heart, but a Llama 73 billion parameter model was handling something like 85% of these queries at a cost which was like, I don't know, $0.0001, like nothing per query. The remaining 15%, 15-20% of the queries was routed to GPT-4 back in the days, cost approximately $0.01 per query, 1 cent per query, 1 cent of the dollar. Net cost was much, much smaller than going 100% to GPT. Approximately 70% cheaper. So, these are the numbers, and very simple math, very simple arithmetic, and a lot of savings. How would you design effective prompt templates for your domain? That's an interesting one. So there is, well, first of all, depends on which domain we're talking about, of course. Institutional assistants, let's say, they need to have some kind of tone. They need to use some kind of jargon. They need to have some kind of style. So the prompt template has to reflect this, this structure. It must have a structure for that essentially is typical of that particular organization. So, for example, technical documentations, technical docs are definitely different than HR or legal, for example. In legal, there is much more legalese and formal language. The tone is different. Technical docs is like dehumanized. You don't want to be fun. You want to be precise with technical documentation. So you need to avoid all the ambiguity of the language, and be very sharp, because it's technical. It's a technical document. You are describing probably an API with a payload, with a message format in JSON format. So you have to be sharp there. Now, typically, well, there is a lot of literature now in prompt engineering. There is even a time in which they were saying that the prompt engineer would have been the job of the future. I never believed that, but in any case, there is a structure that you want to follow. The first is the role. So typically you are an institutional knowledge assistant, blah, 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 for organization, yada, yada. Then you pass the tone in the prompt. So your tone has to be, I don't know, professional, formal, conversational, depending on what it is. Then there is the context. And the context is a section in the prompt where you where you place the retrieved documents from your RAG system, for example. Then you add the constraints, so role, context, constraints. The constraints is, for example, enforcing the large language model to answer only from provided documents, for example. If uncertain, ask for clarification or stuff like that. Or if uncertain, respond that you are uncertain. So make that explicit. In legal, that's very important, for example. If I'm uncertain about something, I'd better make it part of my response, because I don't want you to go to court and be sure that you're saying something that is no longer valid or is absolutely nonsense. And finally, you have the instruction. So the template I typically use is role, context, constraint, instruction, which is typically the user query. Did I answer your question? Probably yes. How would you design effective prompt template for your domain? Yeah, and then the domain, of course, based on the domain, you have a template that you can tune according to, I want, organization name, or the tone has to be professional, formal, conversational, informal, vulgar, whatever. And the retrieved documents is typically an internal format, typically JSON or even plain text, doesn't really matter. How would you measure generation quality? That's a big question, because you have, in fact, many statistical metrics there. Well, first of all, what type of quality are we measuring? We can be measuring retrieval quality, also known as, are the retrieved documents the correct ones, right? So you are assessing, you're evaluating the RAG system and the RAG fetching strategy. So there you go with statistical measure, like precision, recall, all the things that we know from data science and statistics. Yes, guys, it's still there. So retrieval quality is measured typically with precision at number, where at 1, for example, or at 3 is if the documents that should have been correctly retrieved are in fact within the top n, 1, 3, 5. And typically there are indeed these numbers, like I've seen 1, 3, 5, or 10. Same for recall. The second type of metric that you want to measure is the generation quality. And this is like the factuality of the response. So in this case, there are many metrics coming from the literature there, like fact KG, blue, rouge, semantic similarity. These are the metrics. A better approach that I have seen in place is, of course, domain expert review. Of course, you don't need to do that on the entire set of documents or set of queries. You can take some of the most, let's say, key queries that identify your business or your domain and use that, and then rely on the semantic similarity for the same type of fetching to match, and of course the same type of response to match. Another thing is user satisfaction. That's something that we do that all the time. It can be implicit or explicit. You can have a click-through rate, like for example, did the user find the answer helpful? Implicitly asked by the click-through, or explicitly asked, like you explicitly ask the user, hey, was this answer helpful? Thumbs up, thumbs down, and you have that measure immediately. Then of course you track that back, you store that information into your local database. It can be an SQLite or a Postgres. You choose, you pick your poison. It doesn't matter what database you're using. it matters that that trace is under your control. And why is that? Is because when it's time in the future, or probably next week, to probably fine-tune something, you have your pairs, you know what was a thumb up and what was a thumb down, and then you can use this information to fine-tune your embedding model or fine-tune your LLM or both. Or even you can increase the documentation. You can add to the RAG system additional documents that try to cover those particular set, that particular set of queries for which there were too many thumbs down. And finally, there is business metrics. So cost per query. This is something that we also do because it's important that the client understands where is the money flowing and how fast that is happening. If I have a system that works, it will happen that more and more users will use it. Why? Because the system works well. And if more and more users are using it, if I'm using a frontier AI model, all of a sudden I will see a nice spike in my bill at the end of the month. Might not be true if you're using a local model, but what I'm saying here is that when things go well from a quality perspective, they might go bad from an economic perspective because things become more expensive. So that's something that's the business metric that I would definitely consider, and we do consider also in terms of return on investment. I don't want to build a system and place to the client a system that it becomes very good, it helps my business, but it doesn't move the needle that much of my business, but it costs me 3 times because many people are using it. That's a bad system. So even if the system is behaving well, it's working well, it's impacting my business negatively because I don't have enough ROI to justify such a good system. So I'm just entertaining my employees with something that is nice to have, but it's not critical for my business. That can very much be. So that's exactly how I would tackle all the 3 points: retrieval quality, generation quality, user satisfaction, and business metrics. What would you do if retrieval quality plateaus despite optimization? So that's something that indeed can happen. That's a situation where the RAG system has, let's say, high retrieval quality, but at some point you have low user satisfaction. So that's a kind of a subset of this question. Like retrieval quality grows until a certain point and doesn't improve anymore. And then what happens is that it can also happen that user satisfaction goes down even though the retrieval quality stays high or goes higher. Well, there are several questions that I would start asking to the engineers involved in the project. Is it a generation problem? So for example, the right docs are retrieved, but the large language model isn't using them well. Okay, so in that case, I probably have an option of improving my prompt. So do some prompt engineering. Use smaller models with better fine-tuning is another way to solve that type of problem. Another problem that can be is if it's a UI UX problem. So users, for example, don't see where that information came from. In that case, you show the sources prominently, explicitly. Hey, whatever I'm saying here, these are the citations. You have attribution of whatever concept you find in the response. And you let users drill into documents. So that's another important problem to solve. It can also be a confidence problem. Users want certainty, but the system shows uncertainty signals, which in my opinion is actually good because you tend not to hide uncertainty, but frame it. For example, this response is based on X. For a formal answer, contact Y. So that would be a good system, in my opinion, that solves the confidence problem. Is the domain, is it a domain problem or a tone problem? For example, the system sounds too casual or uses wrong terminology. Even though the concept might be more or less there, the way you are putting it to the user's response is like, it's not really ideal because you're using the wrong terminology. You're being sloppy, and if you're being sloppy in a domain like legal, you are having a problem. So what I would do to fix this, I would definitely take 5 power users in the company and ask them a question like, what answers did you not trust, right? And then you try to find a pattern. They will definitely come to you and say, hey, the system is great, but when I asked this thing, this happened, and I, definitely did not trust. Other users who came to us said, I'm an expert, I'm a domain expert in this thing, and I actually was testing the system with things I knew, things I definitely did not need the help of a large language model. I was just testing it out, and it was inaccurate, or I did not trust that answer because I have my background knowledge that allows me to do that. So these are the users you definitely want to talk to. You definitely have to look at the rejected answers if you have one of these feedback systems in place, and check what do they have in common. There's always a pattern in things, unless they are completely random. But the patterns might be very emerging in these type of situations. And then A/B tests. I have a very strong background in statistics where A/B tests was the key to solve many, many problems. I still believe they are the key to solve many, many problems with large language models. Improved prompts or added sources or changed tone. You try with different tones, with different prompts, with different sources, and you do A/B testing. So yeah, these are kind of the 15, I think there were 15 questions. Of course, don't mind the numbers. They have been selected by a relatively large number of questions. I'm glad I received such questions because it means that there is someone listening to the show. So, of course, don't forget to subscribe if you haven't already. YouTube and datascienceathome.com is the official, of course, website. We are on Discord, so don't forget to jump on the Discord server. We have conversations of this type, and you can also propose the next episode that you would like me to cover. Or why not? If you are an expert in this in the domain, you can even come and talk. Always happy to welcome experts on the show. Speak with you next time.